Hello, we will continue solving the gateway problems. This is number 23. It's asking us to find f prime of x if f of x is given by x cubed minus 1 all over the cubed root of x. Now, on the highest level, this function f is a quotient of two functions, right? It's the numerator here divided by the denominator. So we'll be using the quotient rule. But first, before we begin, I think it's helpful to rewrite the denominator not using a radical, but using an exponent. So the cubed root of x is the same as x to the 1/3. This is helpful because it's clear how to differentiate this function. We just use the power rule. So, how does the quotient rule work? Well, what we might do is we might call this numerator function a of x, and we might call the denominator b of x. So the quotient rule asserts that the derivative of f, the function we want, has the following form. It looks like a prime of x times b of x unchanged minus, this minus sign is important, a of x unchanged times the derivative of b. That's our numerator. And in the denominator, all we do is take b of x and square it. So, if we're looking at this form, we see that we really only need to take two derivatives. We need to take the derivative of a right here and the derivative of b right here. Everything else is unchanged. So, often it's helpful to simply copy down the terms that don't change throughout the calculation. For instance, we can just rewrite b of x right here as so. Likewise, a of x and likewise b of x squared in the denominator. There's no need to expand this out or combine the exponents. You can leave it just like this. And in fact, that's preferable because you see the specific derivative matches the general form here. So it's a clear picture of how we got this result. Okay, well, now it's time to differentiate. So our numerator, a of x, that looks like x cubed minus 1. So this will be a straightforward power and then sum difference rule. We're familiar with these by now. Just put this in parentheses here. And lastly, we need to take b prime of x. So now that we have rewritten it as x to the 1/3, we see again this is going to be an application of the power rule. What happens is we will bring down the exponent, which is 1/3, and then our new exponent will be 1 less than the original. So 1/3 minus 1 is negative 2/3. So altogether, this is the derivative of f prime, or excuse me, this is the derivative f prime of x. There is no need to expand or simplify. We are done.